Okay, so last time we got the some angle formulas for sine and cosine, and there's one for tangent too, which you just divide sine by cosine. You got that, which we got from the imaginary plane. They were sine of alpha plus beta equals, I can never remember these, so I have to look at them. Sine of alpha cosine of beta. I think it's plus, right? Plus, careful not to make these the same. Sine of beta cosine alpha. Alright? Angles should be switched. You can write those. So there it is, the sum angle formula for sine, and for cosine it's cosine alpha cosine beta minus sine alpha sine beta. I don't want you to have to try and remember these. Just remember how you get them. These came from, we got them very easily from the Euler's equation by going to the imaginary plane. And we see that these make sense, and they come right from there with no special conditions on them. So what about if we wanted to find the sine of 2 theta? Well, you can probably see already, what if alpha was theta and beta was theta? Then we could just have sine of alpha theta plus theta, which is sine of 2 theta. So basically we just have to go through and replace alpha and beta with thetas. So this becomes, I'll write it out, sine of theta cosine theta plus sine of theta cosine theta, which equals 2 sine theta cosine theta. Those are the same thing. The other one, which does not begin with a S, cosine of 2 theta is cosine of theta cosine theta minus sine of theta sine of theta, or cosine squared theta minus sine squared theta. Remember, we had our Pythagorean identity too. We had 1 plus, we have cosine squared theta plus sine squared theta equals 1. We can use that to make other forms of this equation. Maybe we don't want cosines in our formula, in our result, or sines in our result. We can also write this as, replace cosine of theta with 1 minus sine squared theta. Replace cosine squared theta. 1 minus, well, this is a different blue. 1 minus sine squared theta minus sine squared theta. This equation becomes 1 minus 2 sine squared theta. Alright, if you know this one and this one, you can easily get that one. Suppose we don't want sines in our formula, we can use this equation to get rid of that sign. We have cosine squared theta minus, watch the minus signs. 1 minus cosine squared theta is equal to sine squared theta. So we have, this becomes minus 1, this becomes minus cosine. So we end up with 2 cosine squared theta minus 1. Alright, so this is the 3 forms of this. Sort of 1 here, and then the third one is here. And we can use depending on what we want to do. Alright, let's try a problem with one of these. And it's probably run into a lot, basically when we deal with these complicated trigonometric formulas. Problems that ask you to prove the identity. It sounds a little scary, but basically it's a lot easier. Basically give you an equation and its solution, and you just have to show that it's true. Let's try this one. It's right out of the book. sine of 2 theta over 1 plus cosine of 2 theta. I made a video earlier where I messed this up and I put a minus sign, so I had to scrap that video because I panicked and I said, oh my gosh, things are not working out. 1 plus cosine equals tangent cubed of theta. Now, these problems are a little different than solving for x and things. You basically have to take this one side and make it look like the other side. That's one way to do it. You can take the right hand side and make it look like the left hand side. Or you can do things to both sides to simplify it. Notice here that we can sort of divide out tangent squared theta and reduce this to tangent. But let's resist doing that. I would suggest you first try to always take the left hand side and make it look like the right hand side. You don't have to do it. Often it's easier. And that's sort of the way these problems are set up to be done. Usually the left hand side is more complicated. Anyway, so we'll use our two brand new formulas to get rid of the sine of 2 theta and cosine 2 theta and change them into functions of only theta. So what we just wrote, sine of 2 theta, ends up being 2 sine theta cosine theta over 1 plus cosine squared theta of cosine of 2 theta turns into, what is it, cosine squared theta minus sine squared theta. And then there's tangent squared left. We'll carry everything else along. If these are very long, you can often just wait and put this on at the very end, and so that all equals tangent theta. But this is not that long, so we'll just bring that along. It's not obvious that how this simplified. Although, we kind of want this to turn into tangent of theta. So we want a sine on the top. So we want a cosine in the bottom and the cosine to cancel. So we'd like to kind of leave the cosine squared in there. What if we write 1 minus sine squared theta equals what? Equals cosine of theta. Cosine squared of theta. We know that from our Pythagorean identity. 1 equals sine squared theta plus cosine squared theta. So we can make that substitution. We see a 1 minus sine squared theta. And indeed the bottom then turns into, let me just write the top again. Should I write it out as a step? Sure, I'll write it out as a step, let's see. Well, let's see, 1 minus sine squared theta. This part here becomes a cosine squared theta. And then we still have a cosine squared theta left. So inside all that, I'm not going to I'll write the rest. Tangent squared theta equals, we can add the bottom together, we get 2 sine theta cosine theta. Maybe I'm putting too many steps in here. 2 cosine, because maybe you're way ahead of me. So nicely the 2's cancel out. One of the cosines cancels out, and we're left with, if we write the rest, this equals sine of theta cosine of theta times tangent squared theta, which equals tangent cubed theta. And these kind of problems, make sure and show all the steps, because prove this identity, you can't just write this side and then say, okay, it does equal that. You have to show that it does do that. Alright, so now you're done. And you can put a little box if you want, or 3 dots. Kind of cool math things. Alright, and these are these trigonometric problems. the formula for sine of 2 theta, of double angle formulas. It's just another tool in your toolbox for solving these. We'll move on to using regular algebra techniques, such as quadratic equation techniques, to solve these equations.